Welcome to Live Code Toka. Here we are going to do an overview of the different models as well as their error detection techniques. Okay, so we have first type of model is linear regression, basically a machine that tries to predict y. Okay, so you have an equation with this form and you add an error. Okay, so these have their own formula, and after you find these you have an equation. But how to be confident about this equation? You can do another version of this equation that follows an error, and you do estimators for these type of variables, and you make that error follow normal distribution. Now you have that's all about linear regression. You have tree classification and tree regression. These type of models are used for non-numerical data, okay, and they follow weather entropy, weather Gini index. Entropy is the measure of how new is the information. If it's zero, maybe it's the information is pure, it's not that new, you know. Gini is the probability of choosing random two data, they are the same. If it's zero, the same, they are not new. So the model tries to split using whether entropy or Gini index, but entropy is about leaves, and we want a measure to split between leaves easily and choose the minimum of these measures. So we have diversity index. Diversity index is the probability of yes over total number of data times entropy yes plus no over total number of data times entropy no. Okay, so you choose the minimum, but the model won't do like splits like this and try to come up with so many features. So here you have tree regression. Tree regressions follow mean square error, which is the difference between measured value and mean value. Okay, so tries to come up with minimum mean square error. Here you have unsupervised learning. Unsupervised learning consists of k-means, CAH, and neural network. K-means is the art of guessing points that follow that have their own centroids. Try to come with a point and you have its own centroid. First iteration, it's a random point. The nearest points try to come up with like its own centroid. Try to measure the distance. Okay, try to measure the distance. These group up and they have their own centroid. These group up and they have their own centroid. And if you have the same group, stop. Here you have the same group. What about the error detection for these techniques? Elbow, which is like how to get the optimum k using some of squares within clusters, which is like this, and you have CAH, which is the art of looping with this type of algorithm, which tries to guess the closest type of data. And is this closest or this? No, this is closest. Hop. So we group this, and these are the only groups. We group them. Hop. And the detection for this is confusion matrix. Here the number of data in this centroid. Here the number of data in these centroids. But here we have also what's called neural network with which is the art of finding patterns in reasoning. You have neurons that have weights and you have bias. You have ax plus by plus c, and here you get une sortie or an output value, okay? So you have separation between data like this, and you try to come up with a neural network that tries to separate this data like this, okay? So you have dogs, you have cats, you try to come up with an equation and mathematically, or you try to come up with a logical neural network mathematically like this, using the Heaviside function. But if that's what you are going to do, okay, maybe go for it. But there is a slight better, or not better, but just like how to correct the error, how to correct the error of what you're trying to find, how to come up with an optimum solution by assigning weights. That's what retropropagation does. It uses gradient, which is how to find the optimum solution in a point, minimizing x, or minimizing the function and trying to find x that is null or zero. Try to find the gradient. A gradient is like a derivative of a specified parameter. There is a formula to find this for each parameter, this is the learning rate. You apply this formula so many times, in order to get the optimum solution by just approximating and try to converge the line. When you have so many neurons, that's where the term retropropagation comes. You go like this. The neuron tries to modify its weight and tells the other neuron about the weights it has modified, okay? The neuron then corrects itself. Okay, so this is the idea, trying to correct itself, or in another word, learn.